So we are going to move on to our next subtopic. So what we were saying, what we were discussing. So we were discussing this operation on set, under which we have seen union of set and intersection of set. Okay, these two things we have discussed. Okay, so what we have discussed under union of set, that union of A and B, union of A and B is a set. Union of A and B is a set which is a collection of all the elements of A and B. That was A union B. Okay. Then we have seen intersection of set. Intersection of set A and B was a set that is a collection of element which are common between A and B. Okay, that was intersection of set. Then we have seen Venn diagram for union. So this is the region that represents A union B. Okay. Now similarly, this is the region that represents A intersection B. Next, we will move on to difference of set. Okay. Next, we'll move on to difference of set. Difference of set. Okay. We will use same example as we have used above. So we will use this same example. So let me copy this example. Okay. Just wait a minute. Wait a second. तो हम लोग इसी एग्जांपल को यूज करेंगे टू अंडरस्टैंड हाउ टू फाइंड डिफरेंस ऑफ टू सेट. सपोज वी नीड टू फाइंड डिफरेंस ऑफ टू सेट A and B. So difference of set A and B. Difference of set A and B. So difference of set A and B, it means we need to find A minus B. We need to find A minus B. Okay, so we read this as A minus B. हम लोग इसको पढ़ते हैं A minus B से, but this is not actually subtraction. Okay, this is not the subtraction. What this means is this is a set. Basically, this is a set of set. This is a set which is a difference of A and B, and we read this as A minus B. Okay, so this actually means element of A, elements belong to A, but do not belong to B, This is what A minus B means. Okay, what is A minus B? A minus B is a set which is a collection of elements belong to A but do not belong to B. Okay, now let's see what are the elements A has. A has elements 1 2 3 4 5. So A has element 1 2 3 4 5. These are the elements A has. Okay, now check among elements of A, which are the elements that belong to B. So for example, 3 and 4. Okay, these are the elements that already belong to B. Okay, so what we have written, elements of A but do not belong to B. That means only 1 2 and 5 are the elements that belong to A, but these are do not belong to B. Okay, so basically A minus B will be a set. That has elements 1 2 and 5. Okay, and what are these elements? Okay, what are these elements? These are the elements that belong to only A, not B. Okay, originally A has only 5 elements, 1 2 3 4 5, but among which 3 and 4 already are in set B. So that means 3 and 4 belong to B also. So we have to remove 3 and 4. Okay, so basically from set A we have to remove the elements that belong to A, and the remaining element will be of A minus B. Okay, this is the meaning of A minus B. Similarly we can write b minus a. Similarly we can write b minus a. So what are b minus a? B minus are a are the element which is belong to b but do not belong to a. But do not belong to a means element of b which are not belong to a. Okay, element of b. Now check the set b. This is the set b. Okay, now set b has element 3 4 6 7 8, among which 3 and 4 are the element of a also. So we have to remove this element. Okay, we have to remove this element, and the remaining element will be of b minus a. So b minus a will have elements 6 7 and 8. Okay, this is how you write a minus b and b minus a. So a minus b is the set of element that only belong to set a, not b. B minus a is the set of element that only belong to set b, not a. This is the actual meaning of a minus b and b minus a. Now this was all about difference of set. This is how we write difference of two set. Now we will see set builder form for every for every union of set, intersection of set, and difference of set. Okay, how to write set builder form? Now see, let's see, in the first example, in the first subtopic, union of set, we have seen union of set inside, under which we have seen a union b. Okay, a union b, and we have written all the elements of a and b. Okay, a union b. What was a union b? A union b is the collection of all the elements that belong to a and b. Similarly, we have seen a intersection b. A intersection b is a set of elements that belong to both a and b. Okay, means common elements. Similarly, we have seen difference of set a minus b. A minus b is a set of elements that only belong to a, not b. And we have seen b minus a. B minus a is a set of elements that only belong to b, not a. So now we will write set builder form for a union b. For a union b. So how we will write a union b? So let me use red color. So a union b. So for set builder form, we will assume x is the element of a union b. Okay, now see, x is the element of a union b. Now see here, all the element of a union b, that all the element of a union b belong to either a or b. Okay, see, this is the one, this is element 1. 1 belong to element set a, 2 belong to set a, 6 belong to set b, 8 belong to set b, 3 and 4 belong to both the set, 5 belong to set a. Okay, 5 belong to set a. In this way, every element, I can say every element belong to a or b. Am I correct or not? Every element of a union b belong to a or b. So in set builder form, I will write that x belong to a or x belong to b, because any element in the union, in the union of a and b, belong to a or b. So we will write x is the element, we will write x is the element of a and b such that x belongs to a or x belongs to b. So basically this is the set builder form for a union b. Similarly, we will write set builder form for intersection of sets a and b. So for intersection, we will write x such that x belongs to a and x belongs to b. Okay, we will write x belongs to a and x belongs to b. See, why have I used here and? Because whatever the element in the intersection that belong to both the set. Okay, that belong to both the set. See, 3 and 5, sorry, 3 and 4. 3 and 4 are the element that belong to both the set A and B. Okay, I cannot say or, because 3 and 4 belong to both the set A and B. Therefore, I have to write here x belongs to A and x belongs to B, since x is the element of A intersection B and every element of A intersection B will belong to A and B. Therefore, I have used and. Next we will understand how to write a minus b का set builder form. So a minus b. So I have written here that a minus b is a set of elements that belong to a but do not belong to a. So simply we will write that in the set builder form. So let x be the element of a minus b such that x belongs to a and x do not belong to b. Means in this set only the element belong to a but do not belong to b will be there. So that is why I have written x is element of a minus b such that x belongs to a and x do not belong to b. Similarly we can write b minus a. So what will be b minus a? B minus a equals to x such that x is the element such that x belongs to b and x do not belong to a. Okay, this is how we write b minus a. This is basically how we write set builder form for b minus a. Next, I have to point out a important note for three things. Before that, I forgot to draw the Venn diagram. Okay, just a minute. Set A, set B. So A minus B, what are the elements? A minus B has 1, 2, 5. 1, 2, 5. Common element were 3 and 4. 6, 7, 8. So this was the Venn diagram for basically this was a general Venn diagram. Okay, now see what are the elements that a minus b has. A minus b has element 1, 2, 5. Okay, now check the region that has 1, 2, 5. So this is the region that has element 1, 2, 5. This is the region that has element 1, 2, 5. This moon shape region. Okay, now similarly b minus a have element 6, 7, 8. So this is the region that have element 6, 7, 8. Okay, this is the region that have element 6, 7, 8. This is the region that have element 1, 2, 5. So basically, so this is the region for a minus b and this is the region for b minus a. This is the region for a minus b and this is the region for b minus a. Okay, so I will simply shade the region. So I will remove the element. Okay, this region this is the region for a minus b and this is the region for b minus a. So this is the region for a minus b and this is the region for b minus a. So this is the Venn diagram for a minus b and b minus a. So in exam they may ask draw the Venn diagram for b minus a. They may ask for 1 marks. So you have to just simply shade this region. For a minus b you have to shade this region only this region. Okay, this is the region for a minus b only and this is the region for b minus a. Okay, if if in the question it is said a minus b to shade only this region not the other. Okay, if in the question they have asked b minus a to shade only this region not the other. Okay, so this was all about difference of set. Now we have to discuss one simple point. The point is okay, just a minute. So I have shaded here three regions. This region was A minus B. This region was A intersection B. This region was B minus A. These were the three regions, okay, that we have discussed already. This was the intersection part. This is the intersection part where common elements lies. Now this in this region A minus B means only the element of A lies, and in this region only the element of B lies, okay, not A. So you can see that these three regions have common boundary. For example, this is the common boundary for A minus B and A intersection B. This is the common boundary for A minus A intersection B and B minus A. But you can see there is no common region. Okay, there is no common region between these three set. These three set. Okay, these three set. Which three set? A minus B, A intersection B, and B minus A. There is no common region between A minus B, A intersection B, and B minus A. Therefore, these three are called mutually disjoint set. A minus B, A intersection B, B minus A. These three are called mutually disjoint set. Okay, these three are called mutually disjoint set because they do not have any common region. They do not have any common region, or I can say there is no common element, or you can say the intersection between these three set. The intersection between these three set is a null set. The intersection between these three set are null set. That means there is no common between these three set. Okay, so this was all about the discussion of operation on set. So we will move forward to next topic in the next video.